Okay, there we go. Okay, so today, everybody goes Chromebooks. We are going to talk about tsunamis. This shouldn't take too long, hopefully, because we've already said a lot of this stuff. So I just want to go through some of the important new things for this semester and what they want us to know about tsunamis. So they start off. We've already talked about this earthquake. There was an accompanying tsunami, and so they're going to start off the tsunami chapter with the same event. So this is the Japan 2011, the Tohoku earthquake, which we talked about in the last chapter. Also had a corresponding tsunami that was very bad. So they give you some stats on this one. The Pacific Ocean bottom vertically displaced as much as 9 meters. So imagine all of a sudden the bottom of your pool rises up 30 feet in just a couple seconds. All the water's going to go out. It's just going to go everywhere. And so that was the cause of this tsunami. Was when the earthquake happened, you had about 30 feet of vertical displacement on the ocean floor, which is going to cause a very big wave. Now, Japan was ready for this. It did trigger an automated warning system within seconds. It told people to move to high ground. It started the process of shutting down the nuclear power plants. But one of the problems was the seawall did not keep the water out. So they built a physical wall to hold back the waves. And obviously, it was not enough for a tsunami this large. And so the nuclear power plant got flooded. Their backup power was shut down by the water that flowed in and kept their cooling systems from working properly. And so the power plant just got hotter and hotter and hotter until it entered into nuclear meltdown, which it did. And they're still cleaning up today. So one of the things which we kind of went through last semester, we use the terms from the people who are most familiar with these things. So when we talk about volcanoes, we use a lot of Hawaiian terms because the Hawaiian people have lived their entire existence on a volcano. When we talk about tsunamis, we get the name from the Japanese word. Why? Because the Japanese have been dealing with tsunamis more frequently and more devastatingly than most other people on the planet. And so they have a very apt name for it, and we use that name. So tsunami is Japanese for harbor wave, caused by a sudden vertical displacement of the ocean water, usually triggered by earthquakes or landslides. And so earthquakes are going to be your main thing that can cause tsunamis. Landslides will also work. They do have a couple weird ones down here. Volcanic explosion underwater, which is very rare but can happen. And then obviously an asteroid can cause a tsunami as well, just much, much less frequently. So your main two ones are going to be your earthquakes and your landslides. Now they give you a list of some of the worst tsunamis to happen in modern history. I don't think there's anything too bad. 1755. I guess that's not modern history. But you can see that when they hit, they're usually pretty bad. And so 1755 in Portugal, about 20,000 people died. In 1883, you had about 36,000 people die. They don't even tell you where this was at or what part of the world it was in. The most recent ones, you have your 2004 Sumatran earthquake, which killed 230,000 people. This was a big deal. If you remember this happening at the time, they made a movie about it, which you can watch today, and it's probably just a very sad movie. But a lot of people died in this earthquake, and they're actually going to detail this one in just a second. Here's the Japanese earthquake, the Tohoku earthquake in Japan. This one killed about 20,000 people. And then you got some different ones sprinkled in here that maybe weren't as bad as the rest of these. But tsunamis in general are very, very destructive and take a lot of lives. Like we mentioned, there's really two ways to cause a tsunami. You can move the seafloor by an earthquake so the seafloor can rise or fall, or I can have a landslide happen. And just like you going to the lake, and let's be honest, anybody ever go to the lake and just throw giant rocks in the lake? Yeah, that's the thing kids do. You find the biggest thing you can pick up, you throw it in the lake, and see how big of a splash it makes. The bigger the rock you throw in the lake, the bigger the splash and the wave that's going to come afterwards. So you can imagine like if a whole mountainside kind of collapses in a landslide and all goes down into a river or ocean, that's going to create a big splash and a big wave afterwards. In general, in order to get a tsunami, you got to have a pretty strong earthquake. If you have like a 4.0 or 5.0 earthquake, you might get some waves, but they're not going to be enough to cause any major damage or destruction. So you're looking at a magnitude 7.5 or greater, really to have a serious threat of tsunami damage and loss of life. So, how do earthquakes cause a tsunami? We kind of see the physical parts of this. Your earthquake uplifts or downshifts the seafloor, and the tsunami moves rapidly in all directions, usually inside the ocean. As it nears land, it's going to slow down but get bigger. So the height grows as it gets closer to land, but the wave itself slows down, and then it moves inland, doing what you would think it would do, destroying almost everything and creating a lot of havoc. And last semester, we watched some video footage of the Japanese tsunami that hit. So here's just an all right illustration. I feel like, no offense, I'm sure someone worked really hard on this. I feel like you definitely could have made a better illustration here. Does everybody agree with me? There's not a lot going on. There's not a lot of detail. It looks like someone did this in paint in like 15 minutes. Sorry to the artist. I apologize. These are wonderful huts down here with some little grassy plants, but you could have made a much more technical illustration. So what they're trying to show you is out in the open ocean when things are deep, your waves just really aren't that big. You could be a boat and pass by a tsunami in the open ocean and not even really know. But once it gets on shore and your ocean bottom starts to come up and get more shallow and more shallow and more shallow, your waves slow down. They kind of get closer together because they're slowing down, and they're going to rise in magnitude. So they're actually going to rise out of the ocean and get taller and taller and taller. That's what the tsunamis are going to do. So offshore earthquakes can cause tsunamis to go out towards land or towards sea, which we'll see in a second. So you can have distant tsunamis from way far away from places you can't even see, or you can have local tsunamis from an earthquake that happened in your own part of the world. And so they're kind of showing you here, you can see this direction is going to be closer to shore because we're getting less shallow. The earthquake happens. The tsunami is going to go in both directions. You're going to have one that gets to shore very quickly. You're going to have one that goes out into the ocean and might show up all the way across the other side of the ocean later on that day. So now they're basically talking about landslides and how they can cause tsunamis. In fact, I watched a little video on this from I don't know if it's Discovery Channel or History Channel or something like that. But I watched a little video about this thing where they discovered the world's largest tsunami ever. And it happened in Alaska in this little kind of, they call it a bay. It almost looks like a little river. But basically, it was this V-shaped valley with a tiny little body of water in the middle. And one side of the mountain collapsed. And this whole bunch of rock fell down into the water and pushed a wave up the other side of the valley that got ridiculously high, 1,700 feet. And basically they were looking at this line where all the trees had been knocked away. And you can tell a long time ago, all the trees way up this mountain had been knocked away. And they were trying to figure out what happened to it. And the more they looked, the more it looked like a tsunami. And so this isn't even really out in the open ocean. It's kind of out in the middle of nowhere, but that's where your largest tsunami ever recorded took place. Let's see. All oceans and some lake shorelines have some risk. Yeah, anywhere there's water, you have at least some small risk for tsunamis. Here in North Texas, no risk unless you happen to be right on a lake shore and something terrible happens. But your risk of tsunami here in North Texas is very, very low. Greatest risk is areas near or across from subduction zones, which we don't have either. So the Cascadian Zone, the Chilean Trench, and the coast of Japan. Here's a map that shows you your danger of hurricanes. Notice almost everything in the Pacific Ocean has a decent amount of danger. Why? Because the Pacific Ocean has a lot of earthquakes and a lot of subduction. So you're going to be causing a lot of tsunamis over there. In the Atlantic, almost nothing has any danger of tsunamis. Why is there no danger of tsunamis anywhere in the Atlantic? Because we don't really have earthquakes in the Atlantic. And so there's not going to be any earthquakes starting over here. There's not going to be any earthquakes starting over here. And so there's not going to be any tsunamis going across back and forth. And so it just depends on how much subduction you have and what part of the world you're in as to whether you get these kind of waves or not. Come over here, the other side of the Pacific Ocean, all red all the way around, and even some more red over here in the Philippines and Indonesia. And so, different parts of the world have high danger for tsunamis, and other parts of the world have none. And so this is actually a pretty good illustration. This shows you why you get your tsunami. So I've got my normal subduction happening, and as that subduction continues, I'm going to go down to B down here. So we got A, B, C, and then D. So as my subduction continues, essentially the plate that's being pulled underneath is going to pull down on my top plate. And I'm going to get this bend that happens. And so you can see there's a little bit of a bend right here. It's going to really get bent right here. And so this is my energy being stored up in my earthquake. Once my earthquake happens, I'm essentially going to let go and everything's going to go back to normal. So you're going to see this spring back happen. Once the earthquake happens, I go from this kind of bend back to my normal bend that I started off with in picture A. And all that motion, that's where my seafloor rises. So in the Japanese one, we talked about the seafloor rising like 30 feet. That's where that rise happened. So before the earthquake, my seafloor is way back here. And then after the earthquake, it moves all the way up this way, which is going to push all this water up. It doesn't have anywhere to go but down. Gravity's going to pull it down and start to separate it out into these waves. The closest wave is going to hit this shore, and then the distant wave is going to head out to sea, where depending on where it goes and what it does, it may hit a different shore. So now they're going to talk specifically about the Indonesian tsunami that happened in 2004 that had like 230,000 deaths. This is the one they made the movie about. And so has anybody seen that movie? What's it? Do you remember what it's called? Yes. So very sad story. The people that were involved in the tsunami got hit very, very quickly, and there was almost no warning. As opposed to like the Japanese earthquake, where they had very early warning and people knew what to do. In the Indian Ocean, none of these countries really had any kind of tsunami warnings, and so it was very, very bad. They say that few people knew what tsunami meant prior to the event. Lack of education was a major reason for so many deaths. And many did not know how to recognize a tsunami. One of the things that happens in a tsunami is the water actually goes away from the beach. And so if you're ever at a beach and, outside of like your normal tides, which take hours, if all of a sudden your beach chair was like right next to the ocean and then all of a sudden it's like really far away from the ocean, that probably means a tsunami is about to hit, because just before the wave comes up on land, the water kind of pulls back. And for people that know, like if you live out in Hawaii or if you live in Japan, you see the water kind of go back and everybody knows, oh, that's bad. I need to get out of here. But if you don't know, you see the water pull back. Now all of a sudden I have like new beach to look at, and oh, there's like a little boat that was sunk that I couldn't see before. And people start to go further out and kind of explore, and that puts more people at risk. So here with the Indonesian one, you can see where the earthquake took place. You can see the countries immediately surrounding the earthquake got pretty bad. So Thailand had a lot of deaths. Indonesia had the most. They're the ones that are closest to the earthquake here, with 160,000 deaths. India had quite a few over here, 16,000 deaths as the wave hit over here. Sri Lanka had quite a bit. And you can see that countries even all the way across the ocean over here, in Somalia, Yemen, Kenya, Tanzania, they had deaths as well as the wave went all the way over to Africa and hit that shoreline. It took 8 hours. And so, 8 hours later, word should easily have gotten over there. Hey, there's a tsunami in this part of the world. There could be a wave on the way. It happened 8 hours ago. Just maybe skip the beach today. Don't go to the beach. But there was no warning, and obviously people weren't prepared for it. And you still had deaths over here. Like every death over here was definitely preventable. Even in India, you're talking 2 hours away from where the earthquake happened. 2 hours should be enough to get warnings out, to get people out on the beach and say, hey, you got to clear the beach. We got danger coming this way. But none of that happened because they weren't really prepared for it. So preparation is a huge, huge deal with tsunamis and earthquakes because we have no ability to affect them. We can build a seawall and we can do all the little things that we want to try to do. But if a big enough earthquake happens or a big enough tsunami happens, our ability to affect whether it happens or not is nothing. And so the only thing we can do is educate people and get them ready. Some examples here. A 10-year-old British schoolgirl had learned in school about plate tectonics just before going to Thailand and warned the people around her. And so she got about 100 people to evacuate and probably save their lives. And if we go back real quick, Thailand was kind of up in here. And you can see Thailand doesn't even really have like coastline. So I don't know. It didn't, no way it came around here. Maybe they're kind of merging these together. Maybe Thailand does have some coastline over here. Yes, I see it now. This little section right here is Thailand. They've got a little line that comes down here. So anyways, yes, Thailand does have a little coastline. And this British girl who had learned about this previously maybe saved 100 people's lives. A scientist in Sri Lanka noticed that sea level drop that I was talking about. Noticed the beach, the water on the beach kind of go away and sounded a warning for those that were near them. And then some people noticed animal behavior. The animals always know. They're smarter than us, especially when it comes to natural stuff. And so in one area, elephants started trumpeting and kind of running away, and they ignored the handlers and headed up the hills. So if you ever I don't know where you would be. If you ever see like all the birds leaving or all the animals just like hightailing it out of there, that should be a good sign to you to maybe do the same thing. Trust the animals. They know what's happening, especially the elephants. They remember everything. Education of tsunamis could likely have saved thousands, if not more than that. Here's a picture. This is going to be from Indonesia. This is very much like the setting of the movie that they did. And I don't know. I hate to tell y'all, like, people that took pictures died. But the outcome for the people in this picture and the person holding the camera is probably not good. The likelihood that everyone in this picture survived is probably pretty small, looking at the size of the wave. And the problem with the waves is, even if you survive the wave going in, as soon as it stops, all that water flows back out into the ocean. And so if you survive the initial wave, you also have to stay secured to something and keep from being swept out to sea, where eventually you're just going to be out there kind of struggling to stay up. So very, very dangerous things. Definitely want to take tsunamis seriously. That being said, you're not really going to be exposed to them unless you travel for vacation or something, or move to a different part of the area. So primary effects, obviously your wave of water coming in, it's going to push debris up, it's going to move stuff around. Secondary effects, fires. How does a wave of water cause fires? Fires are always happening with flooding because we bury stuff underground. We bury electrical wires underground, we bury gas wires underground, and when you flood those with water, they're going to have problems. And so fires are usually a secondary effect of floods. Contaminated water supplies. Obviously, if your well gets flooded, you can't drink from that water anymore. And then disease. Usually your sanitation systems, toilets aren't going to flush properly, when you have a major flood happening in your area. So lots of little secondary problems. Possible causes. We already talked about earthquakes and landslides, volcanic explosions technically, and then asteroids, very, very rarely, but it does happen. The asteroid that killed the dinosaurs caused a very large tsunami because it hit kind of like half on land, half off land. So let's see. Not many natural service functions. Yeah. We talk about this, so we'll talk about this a lot this year. That I don't know that they introduced this term. If they did, we didn't go over it in the first PowerPoint. Natural service functions are our way of saying good things that happen in natural disasters, right? So like the wildfires in California that happen every year. Terrible. They burn thousands and thousands and thousands of acres. They destroy homes. People die every year in them. But fires do have good things that they do for the environment. They kind of recycle the natural growth cycle of the forest. They can put nutrients in the soil and stuff like that. And so every chapter, we're going to try to find something good for at least for the earth, if not for the people that come out of these natural disasters. In tsunamis, there's not really a lot to talk about. You could say that they might bring nutrients and sediment from the ocean onto land in that huge wave. They might bring some sediment needed to build a shoreline. They could also take more sediment away as the wave goes back out to the ocean. And obviously, the more we study these bad things, the more we learn, and maybe we can save people. But at the end of the day, if there was a tsunami that happened, there's not a lot of good things to point to be like, yeah, not everything's bad. Tsunamis are pretty much 100% bad. So, human interactions with tsunamis. Like I said, we've got no control here. We can't prevent them. We can't control when they happen. Our activity does not affect how frequently they happen or how bad they are. The one thing that we do kind of do is we live near the oceans. That's just a human habit. A lot of the stuff we need to live is by the oceans, and the oceans are really nice. So I guess we could all just live in the middle of continents and not at the shore or not on the beach, and then maybe we'd be a little bit safer from tsunamis. But that's not something we're going to do. So increased use of shoreline increases consequences. Like I said, the more hotels and buildings you build on the shore, the more stuff you have for a tsunami to knock down. But we're not going to ever stop doing that. A number of strategies for minimizing tsunami hazard. Detection and warning is always going to be number one. Because this first thing up here, there's not a lot we can do to prevent it or control it. So the number one thing we always want to do is warn people. We're going to tell them it's coming, give them plenty of warning. Kind of the same thing with tornadoes. We don't cause tornadoes. There's nothing we can do to make them worse or better. So the best thing we can do is try to give people enough warning ahead of time to protect themselves and have some sort of infrastructure for people to be able to like get in a safe place. Structural control. So they're talking about seawalls and different stuff. If your wave's not too big, a seawall might help out. Tsunami run-up maps. This is important. They have these a lot in Alaska. So when a tsunami warning is sounded, they basically do a little bit of math, and they're like, okay, the earthquake was this big. It was this far away from us. How big could the wave be? And let's say the wave is 30 feet. They say, okay, so we have a map. If a wave that's 30 feet hits this town, where in town will get hit by the wave and where in town will not get hit by the wave? That's kind of important. So they have, for the places that live near the coastline that have tsunamis, they have these maps and they know beforehand. So like maybe 3 or 4 years ago, I showed a video of an Alaskan cop sounding like a tsunami warning. And because they already had the run-up maps, he knew where to tell people to go. And basically the only place they could go in this town that would be safe would be the high school. It was like the highest elevation in the town. And so he's telling everybody, get to the high school. He's like, if you don't go to the high school, everywhere else in the town is going to be too low. You will have some risk of getting hit by the tsunami. Go up to the high school. So that's what those run-up maps do, is kind of give us almost like an evacuation plan if we need to. Land use, where are you going to put your stuff? Is it in the way? Is it going to get knocked down by a tsunami? Probability analysis, where your tsunami is likely going to hit. Education to the people, which again is kind of like detection and warning. And then tsunami ready status. This is actually like a whole thing they may talk about in a second. You have to have like a whole checklist of things available in your city to get tsunami ready status and be like listed as that. So, what do tsunami warning systems do? We have seismographs to detect the earthquakes. We have tidal gauges to try to find those waves because sometimes they're really hard to spot. So we have an automated tidal gauge with like a computer system looking at how big the waves are, along with these buoy sensors to try to detect a tsunami wave before it comes. Information is relayed by satellite to give arrival time estimates, so to try to get stuff very quickly. And then warning systems are used to warn the public. Just like here, it's great if the weather person knows that a tornado is coming, but if you don't have sirens to warn everybody that's not necessarily watching TV, then you're going to have a lot of problems. So you got to have a warning system. And this is their kind of system in the Pacific to warn them of this. All the little purple squares are tidal stations. All the red dots are deep ocean tsunami meters. And then seismograph stations are all in the light blue triangles. So pretty much all over the Pacific, we've got sensors ready to go, looking for earthquakes, looking for tsunamis, so we don't get caught off guard. They probably need something very similar in the Indian Ocean, seeing as they had so many deaths during the last large tsunami. Building designs are going to be important. You want to build your houses and buildings able to withstand big waves as well as the earthquakes. Seawalls are important, but not a end-all be-all. We saw the seawall in Japan failed. How high are you willing to build this? Does it need to be 10 feet? Does it need to be 20 feet? And what are you losing by building a 20-foot wall around your town? Is that important enough for you? After a tsunami, you want to see where the water went, how bad it was, and try to kind of make a map, one of those run-up maps. Before the tsunami, you want to figure out where it could happen. Like, where's the earthquake likely to happen? If the earthquake happens there, where's the wave going to go? How bad could it be? Kind of get a plan going together. And then both types used to plan for possible future events. Obviously, you think about the future, you analyze the past, and try to make a plan. What is this? Maximum run-ups. So this just shows in different towns how big your wave could affect the town. The maximum run-up here in Kahana is only 7 feet. That is in feet. Only 7 feet. So, even a big tsunami, it's not going to get very far in this town. Just the way the topography happens. They're probably very steep right next to the shore. These places out here, which are not steep right next to the shore, they're going to have bigger run-ups of 19 and 27 feet. So you can get a lot of water on land coming into your town. That's going to cause a lot of damage. This is a Huntington Beach, California run-up map. They don't have a lot of tsunamis here, but they've got a map just in case. So they know if something really big happens out in the Pacific Ocean or in Japan or Hawaii or wherever, they can look at this map and know, hey, I got to get everybody out of the red. If I can get everybody out of the red, I will be doing better. We will have most of the people safe, which is kind of interesting. I can be on the beach right here and be perfectly fine, but I could be like miles away from the beach over here and still kind of be in a bad zone. It just depends on what your topography is and where they think the wave's going to go. Land use, natural vegetation may provide defense a little bit if you got some trees along the shoreline, big thick forests. Those are going to resist a tsunami a little bit, although not a lot. Scientists discovered the role of tropical ecology after the 2004 Indonesian tsunami. Yes, so obviously large waves are still going to destroy just about anything. What they found in the 2004 tsunami was that villages that were located behind natural vegetation were partly protected from that wave. And so if you got trees on the beach, maybe it's not a bad idea to leave them there. We know your view would look a lot better. Maybe you get some more tourists if you clear all those trees off the beach. But if you leave them there, it could help you out and be a little bit of natural protection. Development of land must be monitored. You can't just go and cut down all the trees or plant different stuff. That works for a lot of different things, not just tsunamis. What is this? This is an actual map of where your tsunamis went. if you take a little time to look at it, it's actually not too bad. What they show you here is your vegetation and then what was damaged and what was not damaged. And so you can see the areas that have the dark green vegetation don't really get any damage on the backside. The tree areas kind of protected these areas from damage, where if they didn't have any trees, you can see that the wave made it much further inland. So the area of trees kind of stops that wave, where the areas that don't have trees, the wave went much further into land and probably caused a lot more damage. Probability analysis, trying to figure out when your earthquakes are going to happen, when your tsunamis are going to happen. You want to be scientific about it, but we're not super great about this because our ability to predict earthquakes is still not very great. So when an earthquake happens, then we start to warn people about a tsunami, but we're not predicting them too far in advance. Critical to minimize. So education is critical to minimize risk. You got to tell people about it. That's what I'm doing today. Hopefully, none of you will die in a tsunami after today, because now you know. But you want to know, we know the difference between a watch and a warning. A watch is a possible event that's happened. The trigger's there, but they don't know that it actually happened. A tsunami warning means that we've seen the tsunami. It's on its way. Take cover. Educate on behalf of tsunamis. On the behavior, not on the behalf of tsunamis. That doesn't make any sense. Educate on the behavior of tsunamis. That it's not just one wave, but multiple waves. Returning water just as dangerous as the incoming water. That means the wave going out can cause you just as much problems as the wave going in. And then we talked about the tsunami readiness thing. They have to have all this stuff to be considered tsunami ready. So you need an operations center that's operating 24 hours a day. You got to be able to receive tsunami warnings from other parts of the world, have ways to alert the public, develop preparedness plans with drills, and then promote community awareness program to get the word out there and let everybody know that all this other stuff exists. Let's see. Many do not know the signs of what to do in a watch or warning. Actions to take in a warning. If you feel a strong earthquake, leave the beach and low-lying coastal areas immediately. Just get in your car, drive up a hill, go view the top of a mountain or something. Get as far away from the beach as you can. If the ocean recedes, like if the water goes back out, like the tide's going out, run from the beach for higher ground. It's coming very soon. Do not assume that all locations are safe because of an absence of dangerous waves elsewhere. The time between waves can be up to an hour, so stay vigilant. Just because you think one wave has passed doesn't mean it's time to get down out of the building or the tree that you happen to be in. Stay out of dangerous areas for quite a while. Obviously, if you hear the siren, pay attention to it. If you're aware that a tsunami watch or warning has been issued, do not go down to the beach, of course. Waves arriving, there's no time to move inland. Seek a high and strong building. If all else fails, climb a tall tree. If trapped in the water and swept away, look for something to use as a raft. Yes. We could extend this to us here in Texas. As an adult, if you hear a tornado siren going off, maybe just don't assume that it's a warning. 99% of the time when we hear a tornado siren, it's a warning. But if you happen to just be driving around, you hear the tornado siren, maybe get on your phone and check and see, hey, is there any tornadoes coming towards me? It'll only take you a second, but you'd hate to hear the warning and be like, that's nothing, and then get killed by a tornado. So the warnings are there for a reason. Pay attention to them. I do the same thing, but I remind us all that when we come out of a store and we hear a car alarm honking, we never think that it's a thief. We're never like, oh, there's an alarm going off. Someone's getting their car stolen. Maybe I should look over there. It's just, someone hit their alarm button, or, someone didn't turn their alarm off. It's more like an aggravation than anything else. But don't skimp on the tornado warnings. Just check it out. See what's going on. So now, they go back finally to the Japanese 2010 earthquake and tsunami, the Tohoku earthquake and the Fukushima reactor tsunami. Japanese people have studied earthquakes and tsunamis for decades. They knew what to do. They were well prepared. More than 7,750 miles of seawalls protecting about 43% of the coast. So they had systems in place and physical protections in place. Large magnitude and height of tsunami was a surprise. They didn't expect it to be this high. And so almost kind of like a failure of imagination of how bad things could get. But the seawalls weren't high enough. They underestimated the risk because of a false sense of security. A small town with a high wall did survive, but the seawall still delayed the inundation and gave people some time to get out a little bit further. Number 3 was the really bad part. Fukushima Daiichi nuclear power plant was shut down as planned. The seawalls were not enough to keep the tsunami out. The flood that came in knocked down their backup generators, which knocked out the cooling system, which allowed the whole power plant to essentially go into meltdown and become a huge environmental problem. Poor evacuation knowledge and procedures. Some people were told to stay when they should have evacuated. Many left in freezing conditions, many elderly, because power was knocked out and they didn't have a good way to evacuate the people out. And then more deaths from evacuation than tsunami in the area. And so, there's a failure of protocol there kind of to get everything together. And then that's it. We got through chapter 4. And so I will try to have an assignment ready to go for us. I believe that IT has figured out a way where we can use the Google Earth stuff. And so I'm kind of excited about that, and hopefully we can get that going tomorrow. So thank you, everybody. Now we know about tsunamis and how to stay safe. Lights on. Oh, I thought I hit stop, but it didn't hit stop.